to create these ships, we now have to create a ship class. And along with the ship class, we'll also have a class for the players and then the entire game. And I think it's good to store all of that in a separate file. So, because this is really just the GUI, I call this GUI. This is just the graphical user interface. It's just all of the graphical aspects of the game. So anything that you can see up here, but it does not include anything that is hidden underneath the engine of the game. So let's create a new script and we'll simply call that engine. So the engine script will start off with a class for a ship. And here we'll say that a ship, well, a ship is really, it has an X and a Y location, or really it has a row and column position. For now, we'll just keep these random. I mean, we could introduce something where players in a stage 1 of the game position their ships, and then in stage 2, the actual game starts where they, ask each other where their ships are. But we'll just say they're positioned randomly. And if we have random row and column positions for each ship, later on, we have to make sure that the ships are not overlapping, but we'll take care of that later on. So for now, we'll just say a ship really only has one parameter, and that is its size. And then we'll say self.row is equal to random.rand range between 0 and 9. Then we'll say self.column is random.rand range 0 to 9. So that is some functionality of the random module. So we have to import that, import random, and what this little function here does, it just draws a random number between 0 and 9, a random integer. So it's really just 0, 1, 2, 3, up until 9. And then we'll say self.size is equal to, the size that has been specified up here. And then we'll say, well, a ship has a certain orientation. It can either be a horizontally located ship or a vertically located ship. So here we'll say it's, a random choice out of a list of 2 options, horizontal and vertical, H and V. And then lastly, we'll store in another property of the ship class the indexes of the grid, of the board that it occupies. Now, this will depend on how the ship is oriented. If it's horizontally oriented, it's pretty simple. You just take the row and column positions, and then you just add to, so row and column, you infer the starting index, the top left corner of the ship, and then you just add to that until, you've reached the size of the ship, and that's the indexes that it occupies. And if it's vertically, you have to add in increments of 10 because it's going down there. There's 10 positions in each row. And we'll store all of these little maths that I just explained in a separate function, which I'll just call compute indexes. And this should be compute indexes. And now we'll define this separate function, which is also part of the ship class. So compute indexes. First, we have to have the start index. So this is self.row times 10 plus self.column. So just to give you a quick example, let's say the row was equal to 3 and the column was equal to 4. In that case, we would multiply R with 10. So because there's, there's a bunch of rows before that, there's 30 indexes in the rows above row 3. And remember, row 3 is really row 4 because of zero-based indexing. And then we have to add to that the number of columns, which is 4, because it's not in the very left of this 4th row, but it's indented a little. Okay, so this is how this little equation works. And then we'll say if self.orientation is equal to H. In that case, well, what are we going to return? We're going to return a list, obviously. And then we'll say it's the start index plus I for every I in the range of self.size. So, if size was equal to 3, then we would add 0, 1, and 2 to that start index. And this would then be the list of indexes that, specify where the ship is located. And then we'll have elif self.orientation is equal to V. Well, if that is the case, we'll return something similar. So let's copy paste this. But here we'll just have to multiply I by 10. Okay, so let's see if this works. Let's just say S is equal to a ship, and then we'll print S. We get an error. Yeah, we forgot to specify a size. So size is equal to 3, and now we have created a ship object. So let's print s.row. Let's print s.column. And we don't have to print the size, but let's print s.orientation. And then lastly, we'll print s.indexes. Okay, let's do that. So it's a ship that is located in row 6 in column 0. It's vertically oriented, so the indexes are 60, 70, and 80. That appears to be working. So let's run this again. And now we have another ship in 0, 1, again vertical. So now it's 1, 11, and 21. And now we have a ship in the 8th row and 0th column, 80, 90, and 100. Now, is this possible? If you think about this, 100, what is 100? This would be the start of the 11th row of the grid, so that's not possible. So what happens here is that, well, these are random values, and then comes the size, and by pure luck, we could, for example, get 9 and 9. So we are in the very bottom right corner. And if this is the starting index of that ship, and no matter if it's now horizontally or vertically aligned, as long as size is greater than 1, this ship will go out of bounds. So later on, when we'll be randomly creating ships, we got to make sure that this does not happen. But this is something that we'll deal with in a while. For now that we are happy that we have a class that we can use to create ships. Next, we'll concern ourselves with, well, what else do we need? We have to have players. No game without players. So let's create a little player class. What are we going to need for this class? So for this class to work, we have to have a bunch of things. So have our initialization function. We first have to have the ships. So everybody has a list of their ships. For now, this will be empty. And then we have to have the search grids. And I'm just going to call these search. So that is the search efforts of the two players. A square can be unknown, so they don't know whether it's just water or ocean or whether it's a ship in there. And if they know that there's a ship in there, the ship can be in either of two states. It can either still be alive or it can already be sunk. So it's either a hit or a sunken ship. So there's three things really. There's unknown cells, unknown squares, there's hits, and then there is sunken ships. And well, of course, lastly, there's a fourth one actually. Yeah, there's a miss. You know, a square where you know there is no ship in there, but you have already acquired that piece of information. So that's still something, to bear in mind. Okay, so you don't guess the same square twice. But for now, everything's unknown, and we'll just say that search is a list of strings, and unknown squares will be U, misses M, hits H, and then sunken ships will be S. So here, we'll just say U for I in range 100, and well, this U stands for unknown. You don't know what that is. And then we'll just call a function that I'll call place ships. So we'll write a function which will create feasible ships. So this function here will take care of the problem that we have up here, that ships can go out of bounds. And yeah, so this place ships function will take a bunch of ship sizes and then, you know what, sizes equal to, so what's the ships in Battleship? There is the aircraft carrier, which occupies 5 squares. Then I think it's called like a just battleship, you know? And then there is, what else is there? Something called a cruiser, and I think it's a submarine, both 3, and then they have, a destroyer or patrol boat or something, which is just occupying 2 squares. So these are the different sizes, and we want this function to create ships of these different sizes, and then position them on the board, and also take care of, the ships not intersecting, the ships not going out of bounds, and all those sort of things. Let's code this function. Definition, place ships. So this function will take a bunch of different sizes for the different ships that need to be placed on the board. So we are now going to loop through these different sizes. So for size and sizes, the function will generate or create new ships constantly. We'll just try new locations, new row and column positions, and then we'll be checking, hey, are you intersecting anything? If not, that's good. Hey, are you going out of bounds? If not, that's even better. You are a ship that we can work with, and then we're going to be placing that ship on the board. But then we have to stop generating new ship for that particular size, and we'll just use a simple Boolean variable, which I'll just call placed. So if a ship has been placed, we'll set that to true, and otherwise it's false. And now there is this idea of continuous ship generation. We'll use a while loop for that. And this loop will run until that variable is not set to true. While not placed, well, we are going to create a new ship. So ship is equal to ship of the size that we are currently trying to place on the board. And then we'll check if placement is possible. Again, another variable, placement possible, and we'll set that to true. And now we'll try to go through every possible condition that, would violate the rules of Battleship, and then we would set this placement possible variable to false. So for I in ship.indexes, we are now looping through all of the indexes of that ship. And okay, so what do we have to take care of? Well, the first thing, indexes must be below 100. We saw this before where there was an index that was equal to 100, but it has to be below because the grid cells only go from 0 to 99. So indexes must be less than 100. So if any I is greater or equal to 100, we'll set placement. Okay, you know what? I'm just going to call this possible. We'll set possible equal to false. And yeah, I think that's it. We could break out of this loop because we don't have to check any of the other indexes anymore. Placement is not possible. Okay, what else? There's another problem here. So if a ship was right on the edge, the right-hand edge of the board, if we would use this, if you use this function up here, so the ship is horizontally oriented, and if we use this function here, it would now just start counting from the right edge of the screen onwards, and it would go into, out of bounds territory, which in our case would be the ship comes back in from the other side, but one row lower, and that is something we don't want to happen. So it's kind of like the snake in the popular, mobile game Snake, which everybody played years ago. Except that you're not coming in on the same row, but one row underneath. And we have to prevent this. So I'm just going to say ships cannot behave, like the snake and the snake game, okay? This is how old I am. I used to play this game on my phone, long before we had smartphones. So ships cannot behave like the snake in the snake game. And to check this, we'll just go through the next row, next column implied by the index that we are currently working with. And if both of them are different, to the starting row and the starting column of that ship, which is stored right up here in the ship's properties, if both of them are different, then we know that the ship, is doing weird stuff which is not supposed to happen. So here we'll just define new row is equal to I integer division 10, and then new column is equal to I modulo operator 10. And then if new row is not equal to ship row, which is the row of the top left square of the ship, and the new column is not equal to ship.column, in that case, we'll say possible is equal to false, and we can break out of this loop through the different indexes. And then lastly, ships cannot intersect. So that's the next thing that we have to check. Ships cannot intersect. So for every other ship in self.ships. What is self.ships? Remember, we are within the player class, and every player has a list of their ships. So for other ship in self.ships, if I is in the other ship.indexes, we know that this index is already occupied by another ship. So we'll set possible is equal to false. And again, we break out of the loop. Okay, but let's say that we had created a ship of a particular size. We had gone through all of these different checks of whether the ship can actually be placed there. And let's say the possible Boolean was still set to true. This means the ship can actually be placed in the position that was randomly generated. And well, if that is the case, let's place that ship. So place the ship. And now, if possible, that is the case, self.ships.append that particular ship. And then we'll set the placed Boolean to true, which will then make sure that we exit out of this while loop and we'll not be generating another ship of that particular size that we are currently working with in our very outermost loop. And eventually, this function should lead to, the proper number of ships to be generated and all of these ships to satisfy all of these conditions that we laid out right here. Okay, let's see if that works. P is equal to a player, and let's just give it a go. It finished, no problem here. So let's just say print P. It created a player object. Let's print the ships of P. So it's a list, and this list contains different ships. So it says a ship object, and then we have another ship object right here. This is working too. So for ship in p.ships, we'll just say print that ship. Print ship. Okay, now we have the list unpacked. And now we'll go into each ship and print its indexes. And there we go. 80, 81, 82, 83, 84. That is not above 100. It's a horizontally oriented ship. Same thing down here. Here we have a vertical ship, 15, 25, 35. Then same thing down here. And this is another horizontal ship. They are not intersecting. There's no index being reused or used twice. Nothing is behaving like the snake in the snake game. So I think this is working. But just to make sure to get a visual understanding of this, let's write ourselves a little function to show the ships, not yet in the GUI, but, just here in the console. Let's check my indents. I got to be on the first one here. So we're still within the player class. I'm just going to call this show ships. And how are we going to do that? We are going to retrieve the indexes. Well, we have stored the indexes, but no, we have not. So right now, the ships have their indexes within them. So the ship class has their indexes, its indexes right there, but we cannot straight up access them from the player class because we first have to index the ships list, and then we have to go into each ship object within the ships list, and then we can retrieve the indexes. So I think this is kind of not super useful. So what we'll do here, we'll just unpack this, nested structure. So we'll just say that there is a list of lists of indexes. That's a very long name. And so we'll go into ship.indexes for every ship in self.ships. And then, let's just print this very long thing here. And let's create a new player down here. P is equal to player. And then we'll print p dot list of whatever, and player object has no attribute. Yep, I did not store that as a property. And I have the print statement right in here, so I don't have to have this. It works just like that, and there we go. So you can see this is the list of lists with the indexes in them. So there is the first ship, there is the second ship, and so on. Okay, and now we just have to flatten that list of lists. And you know what? I'm just going to call this indexes. And then we'll create an actual property, indexes, same name, but with a self and a dot in front of it to make sure it's an actual property. Now we just have to flatten that list. So this can be done with another list comprehension. So index for, let's just call this sublist in, okay, no. Let's just call this list of lists. This should make it a lot easier to understand. So list of lists, and now we're accessing the index within each sublist of the different lists contained in the list of lists for index in sublist. And now we create the player and we can just say print p.indexes. And if everything is working correctly, we now have our list of lists flattened out. So the first ship, 22, 32, 42, 52, 62. Then comes the second ship, which is, the ship that occupies 4 squares. I think that's just the battleship, 55, 65, 75, 85. Then comes the submarine, I think 5, 6, 7, and so on until we have that very small ship, the destroyer or patrol boat. Okay, so this is working, and now we can use this show ships function here within the player class as well. So we'll start by looping through all of the indexes from 0 to 99 or 100 if we don't include that last value. And then we'll check whether these indexes are within the indexes occupied by the ships of the player. And if they're not, we'll simply print out a little minus symbol, a hyphen. You could also use a dash, a dot, or whatever. It doesn't really matter. And if they are occupied, so that's the other case, the else case, in that case, we'll just print an X. So we can simply type, we print whatever we want to, denote nothing or, water for that matter, ocean. And then we'll print that if I not in self.indexes, else, let's just say we'll make this an X. And what is it that we're looping over? We are looping for I in range 100. And then we want this to be represented in, different rows because we have this 10 by 10 grid, our board. So we'll just say for row in range 10, there are 10 different rows. So for row in range 10, we'll simply print. And now what is it that we are printing? We are printing the 10 values within that row. And remember that right now, this is just a list of values and we need to paste these together because essentially what we are printing out are 10 different strings. And if we would like to join different list elements together in one string, we can just use the string function and then we have to specify what it is that separates the different list elements. And here I'm just going to use a space, and then comes the join function. And now we'll just paste the indexes and then we'll say row. We have to start at -1, multiply that by 10. So if we start at 0, which is what we do, we'll say 0 minus 1 times 10. So that's -1 times 10. That's very low. And then we multiply, and we have it go until row times 10. So at first it's not printing anything, but then starting, if this is 1, this will be row -1, 0 times 10 is 0, up until, 10, and then 2, and so on, and this should really do the trick. Let's just see whether that works. I'm going to print this. We have no syntax error. And now instead of printing the player index, we'll just use p.showShips. And if we do, look at this, we now have a little board, and we can see these X's indicating different ships. So there is one ship up here of size 3, another one of size 3 there. Then we have the 1, 2, 3, 4, a size 4 ship, which is a vertical ship. And then we have the aircraft carrier down here, 1, 2, 3, 4, 5. And then lastly, we have the patrol boat, the destroyer, which is just of size 2. So let's just run this a couple of times and we can see how the ships are allocated differently and how they're just placed in different positions every time we rerun that. So that appears to be working. Great. Now is the time to actually code our second function here, which is our function to not only draw the grids, but then also to draw the ships, the boats. The whole thing won't be too dissimilar from the grid function. So now we'll just define a new function to draw ships onto the position grids, you might say. and then we will define this function, draw ships. And here we have to specify a player, so the function cannot just be run independently from everything else because we have to, visualize the ships of a particular player, so we have to have the player in here. And then we can also reuse this idea from before that we have a left indent and a top indent depending on, which ships we are drawing. And then we'll just say for every ship in player.ships, we have the two locations. I'm just going to copy paste this from up here. There we go. So we have our X and Y location. And bear in mind now it's not simply I modulo 10 and I, divided by 10. So here we'll now say we have our the column and the row of the ship. Remember, this is now a ship object. We created the ship class, so we can now access the row and column positions of this ship directly. So here we'll just say ship.column, and we multiply that by the square size, and then we have also ship.row, and then the same thing multiplied with the square size. After that, we can just say if the orientation of the ship, remember we had this orientation idea, if ship.orientation is orientation, there we go, is horizontal, in that case we will say the width of that ship. So we're now defining this thing called the width. Notice that this is different to this up here. And now we'll say ship.size, well, multiplied with the square size. And then we have our height. And that height is equal to square size, well, simply square size. So right now we are storing the top left location of our ship, which we can extract from the ship.col and ship.row properties. And we are then converting this row and column pair of indexes into X and Y coordinates. And we are also taking care of the indents here already. And now that we have that information, we'll now draw a rectangle, which is either horizontal or vertical. And the reason that I'm now doing it this way here, instead of straight up using the indexes and coloring the individual squares, is that now we can introduce a small indentation so that the ships are not perfectly overlapping the entire underlying grid cell. And you'll see this in a minute, I promise. Now, if the orientation is not horizontal, well, then we'll just say width is equal to square size and the height is equal to ship.size times the square size. And now we'll define a little rectangle. So rectangle is equal to pygame.rect, and then we'll just use our X and Y coordinates, the width and the height. An extra space in here, and I misspelled height. And now we'll simply say pygame.draw.rect screen, and then we'll use green, a new color, our rectangle, and that's it for now. Yeah, so we have to define what green looks like. So here we'll go up here into our global variables, and we'll set green to, well, 50, and let's, now we need a large value for the green component of the RGB tuple, and then we'll just pick 150 there. And this should really be it for the ship class. So now, before we go into the pygame loop, let's define a player. We'll set that equal to player. Of course, we have to import our engine. So from engine, import, well, can I just do this? So I'm going to use an asterisk here, which says import everything. Let's see if this works. And then, okay, now let's refer to it explicitly. From engine, import player, and then we should be able to type engine.player down here. Of course, we need the import call here, and now we get an error, engine is not defined. Obvious mistake. Here I put engine.player, but if I'm importing from engine simply player without the asterisk or anything, I'm explicitly referring to player here. So down here, I don't have to have this engine up here. I can straight up define the player like this. And now in the pygame loop, this is where we will now make use of our new function. So draw search grids, draw position grids, and now we are drawing the ships. draw ships onto the position grids. So now we'll say draw ships of our player. And right now we're drawing them in the top left corner of the screen. Now this threw an error, unfortunately. It says size is not defined. So I'm heading over into the engine script. This is not where the problem is. The problem is right up here. Ship, this should be a dot. Let's run this again. And there we go. You can now see the ships. Let's refresh this. I'm going to run this once more, and you can see the ships. Now the problem here is that they occupy the entire grid cell. So they're just like placed right on top. And sometimes it might be hard to infer where these ships are actually located if they are like perfectly adjacent to one another. So right here, you can only really infer that this ship is 3 squares long, because you know that this ship up here is 5 squares long. But theoretically, this could be a ship with 3 squares here. This is another one of size 3 down there, and this is another one of size 2. So it would be kind of nice if these ships did not occupy the entire underlying squares, and this is what we'll take care of right now. And it's in fact not all that hard, because we introduced this notion of the rectangle here instead of occupying the entire square. So let's just define ourselves a little indent. I'm going to do that before the colors. You know what? Let's separate out the colors from up here. And let's say there's an indent of size 10, just 10 pixels. Remember, an entire square is of size 45. So let's just make that 10 and see whether that works. And now the width of a ship, we'll just say that, well, so the X and Y location, we just add to this the indentation, okay? So plus indent, and let's see what that looks like. And now you can see that the ships don't start at the top left corner, but they are indented a little, okay? But now we have to subtract from the width and the height that indentation times 2 to make sure that they don't overflow into the next cell. So now let's just say minus 2 times the indentation, and here same thing down there, minus 2 times the indent. And then, well, you can just copy paste this idea to down here as well. No, minus 2 times the indentation, and here as well. Let's look at this, and now it's a lot easier to see what the different ships look like. And now, just for, to make this look a bit prettier, let's not use perfectly 90-degree shaped rectangles, but let's just round off these corners a little. And we can do that by saying that these rectangles have a border radius, and I'm going to set that to 15. So that's straight up implemented in the Pygame draw rect function here, okay? So let's see what that looks like. And now you can see that we have some nicely drawn ships in here. And now it's a lot easier if they are adjacent to know which is which and which cell belongs to what ship, okay? This is it. We have now drawn our ships onto the screen. Now that we are able to draw ships onto the screen, well, let's first draw some ships down here and then, some ships up here, because we want the ships of player 1 to be shown down there and the ships of player 2 up here. And now this square, this grid up here and the one down there, this is where we'll keep track of the player's search efforts. So these will be the 2 search grids. So what we'll have to do here is we'll go into the GUI, and where it says draw the ships of player 1, we now introduce our top indent, and let's define 2 different players, player 1 and player 2. And now we'll just copy paste this down here, make this player 1 and this player 2. And player 2, well, it's the top right corner, so we don't have to have a top indent, but we have to have the left indentation. So here we'll need this, and we'll add this down there. Now we'll run it, and there we go. We now have the ships of player 1 and the ships of player 2. Let's run this once more. And yep, that's it. We are now seeing the ships on our screen.